Hello everyone, a very warm good morning. I, Ranjit Kumar, Assistant Professor in the Department of Mechanical Engineering, welcome you all for the lecture series on composite materials. We already dealt in the previous lecture about various types of glass fibers, various forms of glass fibers, properties of glass fibers, and then had a small introduction about manufacturing processes of the glass fibers. Now, today in our lecture, we are going to see about all the manufacturing processes and applications of glass fibers. Okay, now let's get started. Alright, glass fiber manufacturing processes. After all, the raw materials are melted into a bulk and passed through spinnerets. Fiberglass filaments are produced. This pictorial representation of a raw material getting melted into a bulk through which the fiberglass filaments are prepared is as shown in this particular slide. As you can see here, initially the raw material is fed into the bath by mixing with various other materials, and this picture is called as blend of raw materials. Once this blend of raw materials is fed into the bath, there in the bath, the raw material gets exposed to very high temperatures, which make the material to melt. Once the material is completely melted, it then passes through a tub where it will be slowly sent into the feeder. The material from this feeder will be pulled into rods, wires, or sheets based on the requirements by using a puller. Finally, we will be obtaining fiber filaments by performing this procedure. Okay, now let's move on ahead. In general, the filaments are of two types. The first being continuous filaments, and the second is called as stable filaments. Both the filament fibers can be easily understood by looking at the image here in this particular slide. The upper portion of the image is showcasing continuous filament fibers, and the bottom portion of this particular image is projecting or is showing us the stable filament fibers. Okay, I hope you got a minimal idea about how these two different types of filaments will look like in real scenario. Okay, now let's move on ahead. The two types of filaments, as we just studied about, namely continuous filament fiber and stable filament fibers, are manufactured by using two different methods. Continuous filament fibers are produced by using continuous filament process, while the stable filament fibers are produced by using stable fiber process, which will be explained clearly in the upcoming slides of our presentation. Okay, now let's start understanding the two filament manufacturing processes one after the other in detail. Let's start now with the first process, that is continuous filament process. In this process, continuous filaments of indefinite length are produced. We don't have proper length to be defined here. The molten glass passes through spinnerets having hundreds of small openings. These strands of multiple filaments are carried to the winder, revolving at very high speed of more than 2 miles per hour. This process, 2 miles per kilometer. This process draws out the fibers in parallel filaments of the diameter of the openings. Okay, next. A sizing, which is also called as a binder, is applied to facilitate the twisting and winding process, and to prevent breakage during yarn formation. After winding the filaments, they are further twisted and plied to make yarns by methods similar to those for making other continuous filament yarns. The sizing is removed through volatilizing in an oven. These yarns are used for making such items like curtains and drapes. Okay, moving on to the next slide. We have here the next manufacturing process, which is called as staple fiber process. Okay, in this staple fiber process, here in this process, all the fibers with long staple qualities are manufactured. There are many methods for producing such fibers. In one such method, the molten glass flows through the small holes of the bushing where multiple number of jets of compressed air shakes the thin streams of molten glass into fine fibers. These fibers vary in length ranging from 8 inches to 15 inches. These fibers fall through a spray of lubricant and a drying flame onto a revolving drum where they form into a thin web. These fibers in the form of web are gathered from the drum into a silver. Then the yarn is made from this silver by similar methods that are adopted for making cotton, wool, or wool yarns. These yarns are used for fabrics for industrial purposes where insulation is required. In yet another method, the ends of the glass rods are melted, from which drops of glass will fall away. These drops falling flows through draws the glass filaments and they pass on to the cylinder, which is revolving very fast, and they will be done parallel to each other. Then a web of silver is formed if the cylinder moves sideways from here to there and there to here. And sometimes the staple may be thrown off onto the cylinder, from the cylinder onto a stationary steve, which will directly form a silver. So in either of the condition, the silver is then converted into a spun yarn. Okay, next we have the staple fiber, if when subjected to oven, is compressed to desired thicknesses, and the binder which is when applied earlier is cured for giving us a permanently bounded fiber. The subsequent manufacturing of the glass fibers may be executed to direct melting processes. However, in most cases, the glass rods or balls are first made and then they may undergo a variety of further processes, namely nozzle drawing, nozzle blowing, and rod drawing. Okay, now let's dig deep into those processes one by one. First we have is nozzle drawing. As we can see in the figure here, the glass which is fed in is melted in a heat melt tub at 1250 to 1400 degrees centigrades. Then it emerges at the bottom of the melt tub from the nozzle holes of 1 to 25 mm diameter, and it is taken off and drawn. The filaments solidify and are finished and wounded. One can find them in regular shops as various kinds of glass silks, and to make them into webs, the filaments are cut to length, generally required shapes, that is from 6 mm to 21 mm. Okay, the next we have is nozzle blowing. As can be seen in the figure here in the slide, the same as with nozzle drawing. Glass balls are melted in the tub. The melt emerging from the nozzle holes is then taken by pressed air, which draws the liquid glass so as to make fibers of 6 to 10 micrometers diameter. A fluttering effect is caused by the flow of pressed air, which results in fibers of lengths from 50 mm to 300 mm. A lubricant is put on and the fibers are laid down on a sieve drum which sucks them in. The dry web received is held together by long fibers the short ones lying in between them as a filament material. Here you can observe long in between short. Then the silvers of glass fiber material are cut into required lengths and required shapes and so on. The next PRF is rod drawing. As can be seen in the figure here in the slide, by means of a burner, bundles of glass rods are melted at their bottom ends, as you are observing here. This results in drops, which as they fall down, draws filaments after them like this, a small filament. And all these filaments are taken by a rotating drum, a squeegee, laying them down onto a perforated belt. Thus, a dry web is received, which can be wound as a glass fiber silvers. Machine performance being limited by the number of glass rods fed in, the rotating drum may be combined with the nozzle drawing sometimes, which results in drum drawing. So this multiplies performance of the machine. The dry web is again laid down onto a perforated belt and solidified, or after winding it, so as to receive silvers cut for further processing on machines producing wet laid non-wovens. Using and processing glass fibers is not without any problems. For example, the fine pieces of broken fibers may disturb if the workpiece is not well prepared for this purpose. Using the non-wovens to manufacture glass fiber reinforced plastics, it is important that the surface of the plastic material is fully even, uniform. Ends of the fiber looking out may be pulled out or loosened by outward stress like temperature, gases, liquids and so on, which may influence the material characteristics. In some cases, it is advisable to cover up such layers of glass fiber with suitable chemical fibers. Okay, now we are going to see the uses of glass fibers. Uses of glass fibers or fiber yarns. Glass fiber is manufactured in a wide range of fine diameters. Some of them are so fine that they can be seen only through a microscope. This quality of fineness contributes greatly to the flexibility of glass fibers. Various manufacturers produce different types of glass fibers for different end usages. Glass fibers are used for various purposes like first we have is for making home furnishing fabrics, and for making apparels and garments, and for the preparation of purpose tires and reinforced plastics. Okay, right. There are even certain glass fibers that can resist heat up to 7,200 degrees centigrade and can withstand forces having speeds of 15,000 miles per hour. These types of glass fibers are used as filament winding around the rocket cases, exhaust nozzles, and heat shields for aeronautical equipments. Okay, we also have some other types of glass fibers which are embedded into various plastics for increasing the strength. They are used in boat hulls and seats, fishing rods, and wall paneling. Okay, some other types of glass fibers are used for reinforcing electrical insulations. Yet, another types of glass fibers are used for battling for heat insulation in refrigerators and stoves, etc. Okay, now let's look at the other thing. Fiberglass, as mentioned several times earlier, is one of the most commonly used materials in industrial gaskets. Looking at the properties of fiberglass, we can tell why the fiberglass is a preferred material. Its thermal and electrical insulation, strength, and durability are only a few of the many reasons. Some of the most prominent applications of fiberglass have been listed below. The first in our list is aircraft and aerospace industry. The material used in the aircraft and aerospace industry has to be stable and lightweight. As compared to E-glass, S-glass has higher strength and modulus, which makes S-glass a preferred type of fiberglass in this type of industry. Moreover, S-glass also has a higher laminate strength to weight ratio and high fatigue life and high retention at higher temperatures. It is often used to make helicopter armor, flight deck armor, floors and seats of aircrafts. Because S-glass not only has greater mechanical strength but is also non-conductive, offering lower radar thermal profiles. It allows the military to see without being seen. It is also used to make composite blades for helicopters. The second application among our list is construction industry. Fiberglass offers dimensional stability, which makes it an ideal material to be used in construction. Reduced weight, low flammability, impact resistance, and high strength are all the properties that any construction material should have. And fiberglass is everything that it needs to be. Fiberglass is used in the construction of both interior and exterior components of commercial, residential, and industrial constructions, ranging from bathroom fixtures to swimming pool fences to skylights of industrial buildings to solar heating elements. Next, the third application in our list is consumer goods. Fiberglass can be seen widely in numerous consumer goods. It is used in the making of furniture frames and finished goods like utility and decorative trays, divider screens, wall plates, sports equipment, swimming pool and playground equipment, and many more. It is due to its increased flexibility, lightweightness, higher strengths, durability, easy formability, excellent surface and resistance to wear and corrosion that it is used as a primary material in consumer goods. The next application in our list is corrosion resistant equipment. There are a lot of items that have to be made with the material that is resistant to corrosion. These are the items that are to be used in hostile environments and hence have to be resistant to corrosion so that they can last a long time. The items that have to be made with the corrosion resistant material include drainage and waste pipes, underground petrol tanks, cooling towers, sewage systems, flood control structures such as dam gates, and structures involved in energy production industry. Since fiberglass is highly resistant to corrosion and wear, it is the ideal material to be used in the making of corrosion resistant equipment. Next, the next application is electrical applications. Temperature stability and mechanical strength are the properties that make fiberglass a suitable material to be used in electronics. It is one of the most common materials that are used to insulate the electrical equipment in the industries and for an insulation in electronics. Fiberglass coatings are done on wiring to insulate them. Fiberglass is also used in switchgear equipments, transformers, distribution pole hardware, computed parts, etc. The next application is marine industry. Do you know that 70% of the boats are constructed with fiberglass? Yes, they are. The durability and strength of fiberglass are the major reasons why it is the dominating material in the marine industry. One of the major pros of using fiberglass in the marine industry is that it can be molded into different shapes easily. This makes fiberglass extremely easy to work with. The next step in the list is automobile industry. The lightweightness of fiberglass has made it a preferred construction material in the automobile industry. Numerous structural elements of a vehicle are made with fiberglass, such as the belt in a belted bias tire. Fiberglass is also used to make railway fish plates. Okay, moving on to the next slide. Materials with high temperature insulation provide an effective thermal barrier for industrial gaskets. Since fiberglass is durable, safe, and offers high thermal insulation, fiberglass is one of the widely preferred materials in industrial gaskets. They not only provide a better insulation but also help in protecting the machinery, conserving the energy, and ensuring the safety of the professional workplace. This is the reason perhaps why fiberglass is also widely used in industries listed here in the following slides. Starting with the first one, beverage industry. Fiberglass grating is used in many areas like bottling lines and in brew houses. Next we have car washes. Recently the fiberglass grating is greatly used for rust resistance and to give a contrast color to areas that previously looked forbidden. It brightens the inside of the car wash tunnel, making the car look cleaner than it was. Next we have is chemical industry. In this industry, the fiberglass grating is used for anti-slip safety feature of the embedded grit surface and the chemically resistant feature of different resin compounds. The chemicals being used are matched with the resins. Okay, next we have is cooling towers. Since cooling towers are always wet, they have to be protected from rust, corrosion, and other safety issues. Due to the excellent properties of fiberglass, it is used in these towers as screening materials to keep people and animal away from the danger zones. Next we have is docks and marinas. The docks get corroded, rusted, and damaged by the salty seawater. So fiberglass is used here for protection. Okay, and the next we have is food processing industries. In the chicken and beef processing plants, fiberglass grating is used for slip resistance and for holding up to blood, which is corrosive in nature. Most of the areas of food processing also use fiberglass as other grating materials are not suitable. Okay, moving on to the next slide. Fountains and aquariums. All sizes of fountains and aquariums use fiberglass to support rocks to help in circulation and filtering from under the rocks. In large public fountains, fiberglass grating is used to protect spray headers and lights from getting damaged. This also keeps people from drowning in the fountains. Next, manufacturing industry. The embedded grit surface of fiberglass grating ensures slip resistance in the areas that are wet or in places where hydraulic fluids or oils are present. The next is metals and mining industry. Fiberglass grating is used in electronic refining areas prone to chemical corrosion. Other grating materials cannot be used here, therefore. Okay. Next we have is power generation. Many areas of the power generation industry like tank farms, scrubbers and others use fiberglass. The reason for this is the non-conductive property of the fiberglass. Next is planting plants. This application uses fiberglass grating due to anti-slip property of the surface. Okay, and the last we have is pulp and paper industry. The property of fiberglass, which makes it chemical corrosion resistant, is useful in pulp and bleach mills. Recently, fiberglass is used in many areas due to its corrosion resistance and anti-slip properties. Fiberglass composite has taken over the market like a flood. It also replaced conventional building materials like metal and others. With continuous improvements and further developments, fiberglass will continue to improve in quality. Okay, it has successfully satisfied all the needs of the engineering field to a certain extent, and it continues to further satisfy the requirements of various industries. Okay, all right. So I hope every one of you got a clear picture about what a fiberglass is and how it is classified, its different preparation procedures, properties and applications. Okay, so with this we are done about glass fibers, and in the next class we will start dealing about carbon fibers, Kevlar fibers and boron fibers with their properties, applications and preparation in detail. Okay, thank you.